Let's do the critical problems from permutations and combinations. This is class 11th JEE or engineering entrance exam preparation. So along with this critical questions, 5 of the critical questions, we will also learn the concept distinct objects in indistinguishable baskets. Okay, we'll learn more when we come to that. Okay, let's start the questions first. Okay, so line L1 of slope 2 and L2 of slope half intersect at the origin O in the first quadrant. Okay, in the first quadrant, P1 to P12 are the points on L1. Okay, if you see here the graph, the red line is the L1 and the blue line is the L2. Okay, there are P1 to P12 all points on the first quadrant here only. Okay, P1 to P12 on this line and Q1 to Q9 on second line L2. Okay, then the total number of triangles that can be formed having vertices at 3 of the 22 points including the origin 12 plus 9 21 plus origin 22. Okay, so the question is simple, just don't do mistake. Okay, we have to consider multiple conditions. What are the conditions we should consider? Okay, answers are given here. Okay, first condition is we cannot take all 3 points from same line because they are collinear, they cannot form a triangle. Okay, so we have to take a maximum of 2 points from one line, other one from the third point is from the other line. Correct. So case 1, 2 points from L1 and 1 point from L2. Okay, 2 points from L1, that is a total of 12 points, right? So can be chosen in 12C2 into 9 points. So 1 out of 9, which is 9C1. So that is around 594. Okay, case 2 is 2 points from L2 and 1 point from L1. Okay, so this is 9C2 into 12C1, which is 432. Okay, sum of these two is 1026 and we have an answer here. Okay, so if you choose 1026, then this is wrong answer. Okay, you are forgetting one more condition. Read the question carefully. He said 22 points. There are 21. These 22, 21 points only you are looking at. Where is the 22nd point? That is origin. Okay. So we have not drawn a single triangle using origin. Okay. So there is a condition, third condition or third case, which is 1 point from L2, 1 point from L1, sorry, 1 point from L1 and 1 point from, this is L1, 1 point from L2 and origin. Okay, so in this case, it will become 12C1 into 12, 9C1 into 1, which is 108. Okay, so the total is 1134, option C. This is the correct answer. Okay, don't do mistake. Okay, be careful when you do permutations and combinations. Make sure that you cover all conditions. That is the most important thing in permutations and combinations. Only thing mistake can happen is we miss some condition and that number won't be added up or subtracted, whatever. Right? Okay, next. Okay, the number of ways in which the letters A, B, C, D can be placed in 8 boxes of the figure below. Okay, 3 in a row, 3 in a row, 2 in a row, 8 boxes total. Okay, so that no row remains empty. Okay, in each row, at least one of the box should be filled, and at most one letter can be placed in a box. That means in one box you cannot put two letters, only one letter in one box. Basically, this is a placeholder for one letter. Okay, so how many you can do? So this question has two parts, right? One is choose the number of which 5 boxes you will fill out of the 8. Okay, correct. And then second thing is, and it is not 8C5. Okay, 8C5 means it is possible that I choose first row 3 and second row 2. That is also 5, but that is not the case. At least one we should select from each row. Okay, once you choose the 5 cells, second question is very simple. You put 5 letters in 5 boxes, that is 5 factorial way, right? That is simple. Second part is simple. Okay, so two parts to this problem. Find the number of ways to choose 5 cells. Okay, and the number of ways to fill 5 cells with 5 letters, that is 5 factorial. Second part is all, I mean, we are done actually. We need to just do the first part. Okay, let the maximum letters in each row be R1, R2, and R3. Okay, then the condition is R1 is between 1 and 3, R2 is between 1 and 3, R3 is between 1 and 2, and R1 plus R2 and plus R3 is 5. Right? This is what we have to satisfy. We can simply draw a simple table and then find out, because it's not a very big uh, rows and columns, not too big actually. It's very simple. Okay, so I can take one box from R1, 2 from R2, 2 from R3. Okay, in that case, it will become 3C1 and 3C2 into 2C2, which is 9. Okay, because there are 3 boxes, I choose 1, so 3C1, 2 boxes out of these 3, 3C2, 2 boxes out of these 2, which is 2C2. Okay, so multiply them, I get 9. Similarly, make sure that all conditions are covered. Okay, next condition is I take still R1 as 1, R2 as 3, because maximum I am choosing here 1, 3, and then 1. Okay, this case I'll have 6 options, 6 combinations are possible. Next, I will take R1 as 2 cells. Okay, 2 boxes I choose from R1, then 1 box from R2, 2 boxes from R3. Okay, in this case it will be 9. Or I will choose 2 boxes from R1, 2 boxes from R2, and then 1 from R3. This is 18. Okay, 3C2 and 3C2 into 2C1, which is 18. Or I choose all 3 from R1, 1 from R2, 1 from R3. This is 6. Okay, so total is, yeah, 48 ways to choose all 5 cells. Okay, now 5 factorial ways I can fill the letters. So 48 into 5 factorial, which is 5760. So many number of combinations are possible. Okay. Next, read the question carefully. There are 2 parts in this question. First thing is they gave a combination information, that is NCR minus 1 equal to 28, NCR equal to 58, NCR plus 1 equal to 70. Okay, so this is one part. Second part is they gave A, B, and C. Okay, A is nothing but 4 cos t, 4 cos t, 4 sin t, and B is 2 sin t, comma minus 2 cos t, and C is 3r minus n, comma r square minus n minus 1. From where r and n came? From this one. Okay, from this NCR information. Okay, this ABC be the vertices of triangle ABC, where it is a where t is a parameter. Okay, this cos t, sin t is there. This t is a parameter. Okay, if 3x minus 1 whole square plus 3y square equal to alpha is the locus of centroid of the triangle ABC, then what is the value of alpha? Okay, so as I said, there are 2 parts to this one. Okay, first part is find out n and r. Then second part is find out the centroid and the locus of centroid, substitute the xy into this equation. Then you will get the alpha value. Okay, so let's do one by one. Okay, NCR minus 1 equal to 28, NCR equal to 56, NCR plus 1 equal to 70. Okay, so you take any two and the ratio. That way it is very easy to get n and r value, right? So NCR minus 1 divided by NCR, which is equal to 28 by 56, okay, which is 1 by 2. Okay, NCR minus 1 is nothing but n factorial divided by n minus r plus 1 factorial into r minus 1 factorial multiplied by, this is 1 by NCR, so it will be reverse. Okay, n minus r factorial into r factorial by n factorial. Okay, if I simplify it, this is nothing but, okay, r factorial by r minus 1 factorial. So I am left with r here. N factorial gets cancelled, and you have n minus r factorial, n minus r plus 1 factorial. Okay, so I am left with n plus 1 minus r. Okay, equal to 1 by 2. If I simplify this, easily I will know one equation I get 3r equal to n plus 1. This is my first equation. Okay, I take the second ratio, NCR plus 1 divided by NCR equal to 70 by 56, and do the same thing. Okay, I'll get second equation, which is nothing but 4n equal to 9r plus 5. Okay, now here I will substitute my n plus 1. Okay, uh, n plus 1 is 3r, right? So 9r will become 3 times n plus 1 plus 5. Okay, which is nothing but 3n plus 8. So if I simplify, n is equal to 8, and if I substitute the value, r is equal to 3. Okay, so I got my n and r values. So I will get I can easily calculate the vertices C. C is nothing but 1 comma 0. So now let's write ABC here. A is 4 cos t, 4 sin t. B is 2 sin t minus 2 cos t. C is 1 comma 0. These are the vertices of triangle ABC. Okay, which means its centroid is sum of x components divided by 3 and sum of y components divided by 3. This is the centroid. Okay, this is sorry, comma, not dot, it's comma. Okay, in this one t is a variable and satisfies this equation. Okay, now that means this is the locus of centroid. So this point 4 cos t plus 2 sin t plus 1 divided by 3, comma 4 sin t minus 2 cos t divided by 3 satisfies this equation. So directly substitute. If I substitute 3, x is x coordinate. Okay, minus 1 whole square plus 3 y square, which is, if I simplify, this is what I will get 4 cos t plus 3 sin t, 2 sin t whole square plus 4 sin t minus 2 cos t whole square. Okay, if I simplify further, what I will get is 20 actually. Okay, there is 16 cos square t, 16 sin square t, which is 16, 4 sin square t, 4 cos square t, which is 4. So total 20, and these two gets cancelled. So 20 is equal to alpha. So alpha value is 20. Okay. Next, let t be the greatest integer function less than or equal to t. Okay, we know this square bracket t function, right? Greatest integer function. Okay, so let a be the set of all prime factors of 2310 and f is the function from a to z, be the function f of x equal to, carefully check this greatest integer functions. Okay, okay, greatest integer function of log base 2 and x square plus x cube divided by 5. Okay, x cube 5 also has a greatest integer function here. Okay, so if this is what is f of x, then the number of one-to-one functions from a to range of f. Okay, so this is what we need to find out. First thing we should find is range of f. That is important. Once you know the range of f, finding one-to-one is not a big deal. Correct. So let's find the range of f first. 2310 prime factors are 2 into 3 into 5 into 7 into 11. Okay, so we have 5 primes here actually. Okay, now this is what my set A. Set A is nothing but 2, 3, 5, 7, 11. Okay, now f of 2 is, I will replace f of x into with the 2, log to the base 2, 2 square plus 2 cube by 5. First we need to simplify this greatest integer function which is inside, that is 2 cube by 5. Okay, 2 cube 5 by 5 is 8 by 5. 8 by 5 is 1 point something, so this will be 1. Correct, 8 by 5 will be 1.6, so this will be 1, and 2 square is 2, 4 we know, so 4 plus 1 which is 5. Okay, log 5 to the base 2, and this is the greater, it is inside a greatest integer function, right? So this is around 2, 2 square is 4 we know. Okay, so and 2 cube is 8, so this is between 2 square and 2 cube, that is 2 point something is 5 actually. Okay, 2 to the power of 2 point x is 5. Okay, we don't need to know the exact value. Okay, because it's a greatest integer function, 2 power x, 2 dot x is greatest integer function is 2. Okay, so hope you understood how I am solving this function for a given value. Similarly, you should do for each of the primes here. For 3, you will get 3 again. For 5, you will get 5. Okay, if you see here, last log 50 to the base 2. Okay, 2 to the power of how much? 2 to the power of 5 is 32. Correct, 2 to the power of 6 is 64. It's more. So log 50 to the base 2 is between 2 to the power of 5 point x, basically 2 to the power of 5 point x, right? So it's 5 point x basically. Okay, so 5 point x greatest integer function is 5. Okay, so similarly you will do for 7 and 11, which is 6 and 8. So my range of f of x is 2, 3, 5, 6, 8. Okay, now if you see here, there are 5 elements here, 5 elements here, which is good actually. So how many ways I can form one-to-one functions now? You take one element here, it can choose any of the 5, second element, rest of the 4. So it will be 5 into 4 into 3 into 2 into 1, which is 120. So many one-to-one functions you can form. Next. Yeah, let's learn this concept in this video and solve one problem with this concept. Okay, distinct balls into indistinguishable baskets. Okay, what is the meaning of this one? This is a concept of discrete maths actually. Okay, let's say you have one ball and 3 bags are there. 3 different bags are there. How many ways you can put the ball in bags? You can put in 3 ways. You can put any of the 3 bags, right? But let's say those bags are all same. Indistinguishable means exactly same bags. Now how many ways you can keep the ball? If I keep any bag, that ball, which is same actually, right? Because all 3 bags are same. So there is no difference if I put in bag A or bag B or bag C. Okay, all 3 are same. So this is the difference between indistinguishable baskets. Okay, where you are putting the ball. Okay, now let's take 3 balls, 3 identical, indistinguishable. I am calling it as identical, identical baskets. Okay, or bags. Now, how many ways you can keep? Let's say minimum of 1 ball in each bag. Okay, so I can keep any ball in any bag. That's only one way, right? Because all the bags are same. So I will get only ball 1 in one bag, ball 2 in second bag, ball 3 in third bag. That's it. There is no difference if I put ball 3 in first bag and ball 1 in second bag. There is no difference. right? So that is also still one way. So there is a difference when you have indistinguishable baskets, correct? So let's practice this one, and then we will understand this concept more easily, how to solve the problems. Okay, let's take there are 10 balls and 3 identical baskets, and you have to keep 3 balls in one bag, 2 balls in other bag, 5 balls in other bag. Okay, that's how 10 balls are placed. How many ways you can keep? So this is, take the bigger number first, 10C5. Okay, I can keep 5 balls. I can choose any 5 balls from 10 balls. Okay, which will go into one basket. Correct. And the remaining is 5 balls. Out of 5, I will choose three balls and put them in the second basket. Okay. And the last I'm left with 2 balls. Okay. So 2C2, that is, I can choose in 2C2, that is one way. So I don't need to calculate that. That is always one. Remaining balls will go into the third basket. Okay, so many number of ways I can place them, and here this is no different from unidentical bags or baskets, right? This is because you have the numbers are different here, 3 to 5. These numbers are different. Okay, so these selecting the balls will dominate the bags here. Okay, but let's say second condition, 10 balls, 3 baskets, one basket 8, other basket 1 ball, and other basket 1 ball. Okay, so I can choose very simple 10C 8 ways. I can choose first 8 balls, then I'm left with 2 balls. I have to choose 1 ball in 2C one way. Correct, I will say 2C one way. Okay, but it doesn't matter. I have 2 balls and 2 bags. One I have to keep them. So there is only one way I can keep. Or I can write it as 2C1 into 2C1 divided by 2 factorial, because there is a repetition of bags. Equal number of balls in the bags, that I can write it like this. Okay. So this is 10C 8 ways only. Now let's take 10 balls and 3 baskets. 6 to 2. Okay. First one is very simple. 10C6, I can choose 6 balls from 10. Then I am left with 4 balls. I can choose in 4C2 ways. Okay. So this is not my answer. I have to divide with 2 factorial, which is repetition here. Why I should choose this one? Let's say last 4 balls, let's take. A, B, C, D are the balls. Okay. Last 4 balls are A, B, C, D. I choose A, B. Then I'm left with CD on the other bag. So AB is in one bag, CD on other bag. Correct? This is one way. Let's say I choose CD. Okay, so CD goes into one bag, AB goes to other bag. Okay, these two conditions are exactly same because these baskets are identical baskets. They are not different. Okay, this is the difference between the different baskets and identical baskets. Okay, so that means in your 4C2 you are covering both conditions, 2 factorial, because repetition is there, right? So that you are covering. So I am dividing that repetition, 2 factorial. Okay. So this is very important to understand in this indistinguishable baskets concept. Okay. This division is very, very important. Okay. If you are missing this, you will get completely different number. Now 10 balls, 4 baskets, all 4 are different. Then it is very simple. 10C4. Okay. Out of 6, 63. Out of 3 to 3C2, 1C1. That's it, done. But let's say 10 balls, 4 baskets, and 3 are identical. 3, 3, 3, 1. Now see, 10C3 into remaining 7, I will say 7C3. Remaining 4, I will say 4C3. Remaining 1C1. But there is a repetition of 3 bags have exactly same number of balls, which means 3 factorial repetitions are covered. Correct? So this 3 factorial I have to divide. So understand what I am dividing. Okay, I am dividing the exact repetition here. Okay, repetition here. Okay, here also I would say actually into 2C1 divided by 2 factorial. I can say both are same basically. Okay. So if you understand this concept very well, there are questions coming in engineering entrance, especially in JEE mains. There are questions. So very simple concept. Once you know it, I know you can easily practice this, and it goes into the mind easily. Okay. Once you see the terms like unidentical or identical baskets, indistinguishable baskets, same baskets, then you can understand the question is asked about on this concept. Okay. So let's do one problem on this one, which has come in JEE. Okay, 2024 this came actually. If n is a number of ways 5 different employees can sit into 4 indistinguishable offices. Okay, 5 employees should go to 4 offices. Okay, where any office may have any number of persons including 0. Including 0, any number of persons are possible. Then what is n? Value of n. So we understood the table very well now. So let's draw the table only. That's easy. Okay. 5 employees, 4 offices. All 5 can go into one office. Okay. So you don't need to say again 0500, 0050. All are covered in this, right? Because all offices are identical offices. Okay. So 5C5 is, that is one way. 5C5 is one way. Now 5 employees, okay, they go to 4, 1. Only 2 offices, other 2 are 0. Now this is 5C4 goes to one office. Okay, 5C4 ways. Then remaining one goes to the second office, which is nothing but 5C4, which is equal to 5 factorial by 4 factorial into 1 factorial, which is 5. Okay. Now 5 employees, they go in this pattern 3 and 2. This is also exactly same. 3C, 5C3, and the remaining 2 goes to second office. So that is only one way. Correct. So 5C3 is nothing but 10. Next, 3, 1, 1. 3 employees goes to one office, 1 employee goes to second office, another employee goes to third office. Okay. So in this one, first one is 5C3 into remaining 2, 2C1 divided by 2 factorial repetition, right? Right. So this will be 10 if I simplify. Okay. Then 2, 2, 1, 0. Okay. So 5C2 into 3C2 divided by 2 factorial because repetition is here. Okay. And then 2, 1, 1, 1. Okay. This is 5C2 into 3C1 into 2C1 divided by 3 factorial, which is equal to 10. Okay. So these many number of ways employees can go. Okay. One thing you carefully see here, I have started writing in a order. Okay. Either you can take from bottom to top or top to bottom, but there is a order. First I took all 5 in one. Then only one employee I moved out. Then I moved 2 employees out. Okay. And then 2 employees into one office. Then 2 employees distributed into 2 offices. Okay. Correct. And then I moved one more employee out. Then 2 employees in one office, 1 employee in third office, and then distributed them. Right. This way you will systematically follow. You will not miss any condition. Okay. So please follow this very in this order. Actually, this order is very important, and this order comes only by practice. You have to practice this. While practicing only, you have to write in this order. Okay. You can do your reverse also, that's also fine. 1, 1, 1, 2 you can start with, and then go up. Actually put everybody into one office last. Okay. Both are same. Okay. But you have to follow some order. Okay. So now the answer for this one is sum of all this, which is 51. This is the answer. Okay. Next. Yeah, thank you. So these are the critical problems which I choose as a small video. Okay, these are more important. Okay, because easy problems everybody will solve. Critical problems are the one which will differentiate you from the others. So keep doing much. Till then, I'll make up more videos. Thank you.